Hi friends, see in part 1 video we discussed about stress strain graph, that is behavior of the wire under gradual increase of load. So you can see in part 1 we have drawn one graph A, B, C, D, E, F, some points are located for stress values and strain values, strain on x-axis and stress on y-axis. Now here we will be discussing about various points A, B, C, D, so on and so forth. Now from the graph it is very clear, you can see what is OA. OA is a straight line. OA is a straight line which is indicating about what? Proportionality limit. Proportionality limit. అంటే ఏంటి అర్థం? Here Hooke's law is valid. That means longitudinal stress is directly proportional to longitudinal strain. Up to A, Hooke's law is valid. That is why it is straight line. Now after that you can see what is OB. See, B, small curvature is there. So what does it mean? After removing the load from the body or material, the body can regain its original position. That is B point. So B tells about, that is OB, elastic limit. B tells about, that is OB line, tells about elastic limit and elastic nature. That means after removing the external force, the body will regain its original shape, size and volume. That is the B point. Now after B point, what happens? If some more load is added to the material, then what happens? It becomes fatigue. What is meant by fatigue? See, what is elastic fatigue? That means if same force is applied number of times at same time, same point, the material becomes weak and finally it becomes tired and it breaks. That point, that definition is called as elastic fatigue. Same force, same point, number of times you apply, the material becomes weak and finally it is ready to break. That is called as breaking point. And that principle, the definition is called as elastic fatigue. And after B point, what happens? If some more load is added, the B point will extend to C and it goes to permanent set. It won't come back and it occupies a new origin, O dash on x-axis. And C point is telling about permanent set. What the C point is telling us? It is called as permanent set or plasticity. The material behaves like a plastic, not elastic in nature. That means it goes and stays there, it won't comes back after removing the force. Clear? So C is called as permanent set. Now the point comes. What is after point C? See, after point C, if you apply some more load to the material, now the material starts yielding. After C, the material starts yielding. What is meant by yielding? That means the material lateral strain will be there. That means diameter go on decreasing and the wire becomes very thin and finally it stretches and finally it breaks. And therefore this CD line tells about ductility. CD line tells about ductile nature. That means the material, how much ductile, means stretching property. So after coming to D, the material is ready to break. That point is called as breaking point and the stress required to break the material is called as breaking stress. మీకు అదొక చెప్తున్న పాయింట్ ఇక్కడ C తర్వాత the material is subjected to lateral strain, diameter decreases, it becomes into thinner, very thin and finally it stretches and finally it breaks. So DEF graph indicates the breaking point. DEF, it may break at D or E or F. So DEF is called as breaking point of the material. So here we are learning so many points here. Those points are point A, Hooke's law, that is proportionality limit, obeys up to A. B, elastic limit, elastic nature will be there. After removing it regains its original shape, size and volume. C, permanent set of the body, it won't go back. but it occupies another position on the horizon at O dash, and DEF tells about the stretching property, and finally it breaks. Okay? Right. Now let us go to the next point. Let us learn some more terms in this one. Just now I told you about what is ductility. Stretching property of a material is called as ductility. Okay? Stretching, I'll rub this graph. Graph is also over now. No need of graph now. So, we have learned so many terms. Ductility. Ductility. That means stretching property of a material. Okay? With this we can know how much a material can be stretched and where it is breaking. Okay? Next, brittleness. Brittleness. B-R-I-T-E. Brittleness. What is brittleness or brittleness property? Breaking property. For example, glass is a brittle. For example, glass material is a brittle. It breaks very easily. Okay? So these are some important points you have to learn this regarding the graph, stress versus strain, behavior of the wire. Now apart from this we have one more point also, malleability. What is meant by malleability? Making into thin rectangular sheets iron material. Iron material making into thin rectangular sheets is also called as malleability. That is another property of the material. Clear all of you? So these are the main things you have to learn, and this question sometimes will be asking for 4 marks also, or you may ask for 8 marks depending upon the requirement. Clear? Now let us go to the next derivation, which is very important. Okay? Which is very important. That is 4 marks again, which is also regularly asked in the examination. That is work done in stretching a wire, which is stored in the form of potential energy. For example, this is a wire of length L, diameter D, radius R. Now some force is applied, external force. Okay? So what is the work done? Let the work done be small dw dx, and we know from Young's modulus y is equal to F by A, stress by strain, or Yx by L into A is equal to F. From this equation, put it here. dw is equal, in the place of F I can put it Yax by L into dx. This is what? Small amount of work. నాకు మొత్తం వర్క్ కావాలి. అప్పుడు ఏం చేయాలి? యూ హావ్ టు ఇంటిగ్రేట్ ఇట్ ఫ్రమ్ 0 to w here and here from 0 to x. So left side w is equal to constant y, a constant, l constant, integral 0 to x dx, and this is nothing but what? X power n dn, x power n plus 1 by n plus 1. So what is w? yal by x square by 2 integral of x dx, limit 0 to x. So this goes like this, ya by l, upper limit x place lo upper limit పెట్టండి, square by 2, lower limit పెట్టండి 0 whole square by 2. This is 0. So finally what is the work done in stretching the material wire, which is stored in the form of potential energy? That is equal to ya x square by 2l. This will be in, of course, joules, named after scientist Prescott Joule. This question carries 4 marks in IPE. Very important, please. Note down? Right, very good. Now, this equation you can change it in different forms. See, same equation, you can write it in different forms. Let me tell you. So depending upon the requirement, you can change this equation. Now see here, I got equation work done potential energy is equal to ya x square, I'll write x into x by 2l. Now in the examination you may be asking work done per unit volume. Divide by volume, both sides. Work done per unit volume. So therefore W by V volume, Y, A, X into X by 2 into, what is volume? Volume and area into length. Put it here in the place of volume. Area cut. Now see here, work done per unit volume, I can write it as, see here, what is Yx by L? What is your Young's modulus formula? Stress by strain. What is Young's modulus formula? Stress by strain, Y into X. Y into X by L is equal to F by A, stress. So, this place lo Y into X by L in write cheyavani, I can write stress by 2 into what is left over, A cut అయిపోయింది ఇక్కడ, X by L is left. What is X by L? Strain. So, same formula derivation, I can write it in the form of stress and strain. Elaga? See, work done per unit volume is equal to 1 by 2 into stress into strain. Leda total work done is equal to half into stress into strain into volume of the wire. Volume of the wire is nothing but area of the wire, pi d square by 4 or pi r square in terms of radius or diameter into length of the wire. It will be given. Okay. This is another form of writing the work done, potential energy. Clear all of you? Now let us write in another form. So many forms are there. You can change the same formula. You can change the same formula in next form. See, next form ఏంటంటే work done. See here, work done per unit volume. Take this volume here. Half into. See here, already we know what is Young's modulus. Young's modulus means stress by strain kada. Now Young's modulus into strain is equal to what? Stress. So this formula half into stress. What is stress? Young's modulus into strain into again strain. అంటే work done per unit volume, I can also write it as in this form. Half into Y into strain into strain, that is strain square. If in the examination strain is given, Young's modulus is given, then you can apply this formula. Work done per unit volume. Clear? This is one way. You can also explain another way. Again, see. Work done per unit volume is equal to half into, now I express in strain, now I will express in stress. Stress lo రాయొచ్చు చూడండి ఒకసారి, half into, same formula again చూడండి, stress into strain. Now ఇక్కడ నుంచి చూడండి, what is strain? What is strain? Strain is equal to stress by Y. Now I can write the equation W work done per unit volume is equal to half into, already stress is there. What is strain? What is strain? Stress by Y. So stress by Y. So the equation goes like this. Work done per unit volume is equal to 1 by 2 into stress into stress. Stress square by Y. So various formulas you can change depending upon the requirement. Clear? So this is the derivation for 4 marks in the IP examination. Now let us go to the last version of this chapter, mechanical properties, to end up this chapter, that is Poisson's ratio. A scientist named Poisson has given a ratio regarding lateral strain and longitudinal strain. Lateral strain, and when any wire, for example, see here, last one topic, Poisson's ratio, that is sigma p. So simply you can tell it as lateral strain by longitudinal strain. అంటే అర్థం ఏంటి? minus delta d by d by delta L by L. This is the exact definition of Poisson's ratio. Poisson's ratio అంటే ఏంటి? ఒక మెటీరియల్ వైర్ ఏదైనా తీసుకొని, suppose it is having a length L, F is force applied externally, if D is diameter and R is radius. If you go on increasing the length, diameter decreases, that is called a lateral strain. Diameter తగ్గిపోతుంది, రేడియస్ లెంత్ ఇంక్రీజ్ అయితే. ఆ రెండింటి యొక్క నిష్పత్తి, రేషియో, the ratio of lateral strain to longitudinal strain is called as Poisson's ratio. So I can write Poisson's ratio as that is sigma p is equal to minus delta d by d, decrease in diameter, change in diameter, original diameter, by increase in length, delta L by L. Very, very important formula. And the scientist has found also, practically he has given some values. Aventante, see, Poisson's ratio value, okay, greater than equal to -1, less than equal to half, that is plus half. This is called as theoretical value. Theoretical value. And the value, Poisson ratio is greater than equal to -1. Greater than equal to -1, less than equal to half. అలాగే ప్రాక్టికల్ వాల్యూ కూడా ఉంది, సిగ్మా పి, పాయిసన్స్ రేషియో గ్రేటర్ దెన్ ఈక్వల్ టు 0, లెస్ దెన్ ఈక్వల్ టు ప్లస్ హాఫ్. దిస్ ఈస్ ద ప్రాక్టికల్ వాల్యూ. సి పాయిసన్ రేషియో ఎగ్జామినేషన్లో క్వశ్చన్స్ ఇవి అడుగుతున్నాడు ఈ మధ్యన. ఈ నీట్ అండ్ ఎంసెట్ దే ఆర్ ఆస్కింగ్ వాట్ ఈస్ ద థియరిటికల్ వాల్యూ ఆఫ్ పాయిసన్స్ రేషియో అండ్ వాట్ ఈస్ ద ప్రాక్టికల్ వాల్యూ. థియరిటికల్ వాల్యూ ఏంటి? పాయిసన్ రేషియో గ్రేటర్ దెన్ ఈక్వల్ టు -1, లెస్ దెన్ ఈక్వల్ టు ప్లస్ హాఫ్. అలాగే ప్రాక్టికల్ వాల్యూ ఏంటి? గ్రేటర్ దెన్ ఈక్వల్ టు 0, లెస్ దెన్ ఈక్వల్ టు ప్లస్ హాఫ్, less than equal to plus half. So these are very, very important values you have to put in your mind. In the examination they are asking regularly. Okay, and I think this will be the end of the chapter mechanical properties of solids, that is elasticity. We will be meeting again in our next chapter, that is mechanical properties of fluids. Okay, right.